The upstream petroleum industry prepares for oil spill response in all types of conditions, including those found during winter months. Although a response to a winter spill on a river or lake presents unique challenges, an ice cover does offer some advantages over a response in open water, such as an ice cover can slow the current speed and subsequent downstream migration of oil as it tends to calm waves and turbulence. Typically, there is an absence of migratory birds, which can be a serious issue in the open water season. Freezing can lock oil inside of its layers and can be recovered and managed. An oil spill migrating downstream in a river with an ice sheet will generally follow the current, with some accumulations becoming trapped in ice depressions, rough areas, or in back eddies. Oil trapped under the ice in a lake is not as susceptible to movement by currents and will spread out laterally, and like a river, if it finds an opening in the ice, it will surface. Snow and ice are susceptible to absorbing oil, and in some cases, the contaminated material will need to be removed for eventual oil-water separation. The response tactic strategy on a lake or river with an ice sheet is to create an opening or slot in the ice sheet where the oil surfaces and is recovered if safe to do so, or dispose of the spilled product through in-situ burning. Once a spill is discovered and the emergency response plan is activated, the spill is reported and equipment and manpower are identified and dispatched, with the typical steps taken as: identify the equipment deployment site location, develop an ice safety plan that includes the hazard assessment, safety controls, site safety plan, and outlines the containment and recovery strategy. Assess the ice weight-bearing capacity, current speed, and current movement pattern. Clear the area of snow and mark the location of the ice slots. Cut the slot and remove the ice blocks. Recover oil that migrates into the slots. Take steps to keep the ice slot from freezing. Remove contaminated ice and snow. Search for accumulations upstream of the slots to the source point of the spill. Spills to water bodies under an ice sheet can present multiple challenges. It is important to ensure a deployment site that will provide enough space for the equipment and crews needed to effectively and safely contain and recover the product. Bear in mind that your equipment needs may change depending on the weight-bearing capacity of the ice that must be monitored on an ongoing basis, so available space will need to be as flexible as possible. Record information that can be referenced through the response to keep responders and surrounding stakeholders safe. Personal protective equipment needs to be adequate for working from airboats, conducting ice rescue, and for containment and recovery site preparation and operations. Ensure that all members understand the objectives of each task. Write them out and discuss them in a safety briefing. Ensure that each person understands their role, specific hazards to the work they will be doing, and who their supervisor is. Indicate on the ice safety plan once each crew has been briefed. Record the results of your ice evaluation and proposed strategy. The ice assessment is conducted by a crew in an airboat or a two-man crew harnessed and secured by rope and manned by the safety and rescue team on shore. Ice rescue measures such as reaching poles or ladders, throw bags, and manned sleds will be in place and deployed by the safety and rescue team should the ice assessment crew fall through the ice. The assessment includes drilling a series of holes in the ice and measuring the thickness, measuring the current velocity and current direction in order to identify the current pattern. In addition, a block of ice is removed in a few locations to identify the quality of the ice. That includes a measurement of white ice and blue ice that is used to calculate the weight-bearing capacity. When using Gould's formula to calculate the effective ice thickness, WCSS recommends using the low-risk category that can be found in Table 3 of the WorkSafe Alberta Code of Practice Working on Ice Guideline. It is also important to note that fluctuations in temperature prior to the assessment can have an impact on the weight-bearing capacity, and visual signs of cracking in the ice may lead to a reduction of the ice sheet's ability to sustain heavy loads. At the desired location, the snow is typically removed with equipment that meets the weight-bearing capacity criteria, and the slot outline is marked on the ice surface in a J-shaped pattern, with the upstream opening that faces the fastest current and the rest of the slot at about a 30-degree angle to the current. The placement of the ice slots is based on the containment and recovery objectives. For example, the first series of slots could be in a relatively close proximity to the source point of the spill, and another series of slots further downstream to contain and recover the spilled oil's leading edge. The slots should be staggered so that when completed, the slots will intercept any oil migration downstream in the channel, or in the case of a lake, located to prevent lateral spreading under the ice. The width of the slot should be about 1.5 times the thickness of the ice, and no more than a maximum of 1 meter, with a gradual flaring at the downstream end to accommodate ice block removal. At the downstream end of the slot, there must be enough room to utilize the recovery skimmer. Ice blocks in a lake environment can be pushed under to avoid the heavy lifting if no mechanical support is available. In a river environment, consideration must be given to the depth of the water when pushing blocks under, as it is possible that blocks can become jammed in a shallow area, which leads to damming of the recovery site. A third option to remove blocks where heavy equipment is not an option is to combine the use of a capstan winch with an A-frame lifting device. It is good practice to move ice blocks away from the slot and store along the shoreline and remove heavy equipment off the ice sheet when not in use. The type of equipment selected to create the ice slot is based on the site conditions, weight-bearing capacity of the ice sheet, and ice thickness. Chainsaws are often used to cut and remove ice blocks to determine the weight-bearing capacity of the ice sheet. They can be used by certified chainsaw operators or by operations staff using a saw in a chainsaw carriage. Chainsaws can be used to cut the ice slot, provided the ice thickness does not exceed the length of the blade. WCSS saw blades are angled within the cage so that the block is wider at the top than at the bottom for an easier retrieval. Excavating equipment is used to dig a trench or opening in the ice when the excavator can operate from the shoreline or when the weight-bearing capacity is adequate to support the excavator. If a rubber-tired hoe is used, it should be equipped with a frost bucket and ice cleats on its stabilizer pads. There are several options that can be used to recover the oil that is contained in the slot, including drum skimmers, disc skimmers, vacuum trucks, or portable vac units. Sorbents can be used to recover residual products or smaller amounts that can't be recovered mechanically. In some cases, in situ burning may present itself as the most viable option, where there is a concern for the safety of responders, and when conditions are favorable, and a burn plan has been approved by the regulator and landowner. Refer to the WCSS Oil Spill Contingency Manual for how to build a detailed plan and ensure all factors are being considered. Dimensional lumber like plywood or boom may be placed in slots at the outer perimeter of the spill to provide additional containment and to prevent oil from migrating laterally. Responders use screening material or shovels with drilled holes to remove the ice buildup from the slots and cover it at night to prevent freezing over. It is critical that the slots are fenced off and appropriate lighting is installed to warn people and wildlife that the area is not accessible. Signage both upstream and downstream from the slots is necessary. WCSS has 3 winter response units that can be utilized in the event of a spill to a water body with ice cover. They are located in areas T in Grand Prairie, IJ in Atchison, and VR1 in Lloydminster. WCSS member companies are encouraged to find as many opportunities as possible to work with equipment available to them prior to the spill. Ensure that yours is a member in good standing and sign an equipment lease agreement before you plan any training with the equipment. Our focus is your preparedness.